Greetings, everyone. Today we're going to explore the order of operations. And for this lesson, we do have a foldable. It'll be posted on Google Classroom, or if you're at school, you can pick one up. Otherwise, you can just jot these down in your notebook. Remember that when you see a pencil, that means we want to jot this down. Let's go through a few definitions first. In your foldable, you should see the word simplify. Simplify means you're going to replace the numerical expression with the single numerical value. Replace the numerical expression with its single numerical value. Remember, if you need to pause at any time to write things down and then continue listening, please do so. So an example of simplify, you don't have to jot down my writing here, but if I just have something like this, okay, that means I just want to simplify that and get it down to a single number in the end. That's going to be our main goal today. All right, in your notes, I have this graphic here for you. And when we simplify, there is an order to which we need to simplify to get to the right solution. So the first letter in this acronym called PEMDAS is P. P is for parentheses, and that means we're going to perform any operations that include grouping symbols. So please jot that down. Perform operations in grouping symbols. The reason why we say that is sometimes instead of a parenthesis, you might have a bracket. That's a grouping symbol. We use it the same way. Step 2, E. E stands for exponents. You're going to perform and simplify any powers or exponents that need to be taken care of. Step 3, you'll notice that there's actually two operations here, M and D, multiply and divide. Now, the reason why they're the same color is you're not going to multiply then divide. That's where we have to be really careful. You're going to multiply and divide left to right, meaning whichever one comes first on the left is the one that you take care of first. That's going to take some practice. And the last step is add or subtract. You'll notice it's the same color. And again, the reason why is you might have a whole bunch of adding and subtracting left to do, but what matters is that you take care of it from left to right. So again, if you need to pause to jot these down, please do so. And what we're really going to work on is remembering this acronym, PEMDAS, to help us out. All right, let's take a look at some examples, and we're going to follow the PEMDAS rule. The acronym is going to help us. So do I have any grouping symbols? Nope. Do I have any exponents? Nope. Do I have any multiply or divide? Yes. So I want to start with the one that's furthest on the left. Now, here's my suggestion. I always recommend underlining the step that you're doing. So if I'm starting on the left, 25 divided by 5 is 5. And anything that's not underlined falls down. All right, well, I still have a multiply or divide, so I'm going left to right. The next would be underline the 5 times 2. That gets me to a 10. What's not underlined is the plus 1, so it falls down. And the nice thing is, when you get down to one step, it doesn't matter what it is, because it's the only thing you can do. So in this case, the 10 plus 1 simplifies down to a value of 11. All right, let's take a look at example 2. Again, we're going to go through. You've got it on your notes, so you shouldn't have to write it every time. Let's go through the PEMDAS rules. Do I have any parentheses? Nope. Any exponents? Nope. Any multiplying or dividing? Yes. If I read left to right, the first multiply or divide I see is 2 times 1. So I'm going to underline it. 2 times 1 is 2. Everything else falls down. All right. Next, adding or subtracting. And we want to go left to right. So the first thing I see is 7 minus 4. That's the first left one. So let's underline it. 7 minus 4 is 3. The plus 2 falls down because I didn't use it yet. And I only have one operation, so that makes it easy. 3 plus 2 gets me a simplification of 5. All right, let's take a look at example 3. Now this is unique, okay? So let's put a star by this one. This one doesn't follow the typical rules. When you have a big fraction bar, okay, so maybe with your pencil, go and accentuate this fraction bar. Treat this like 2 separate problems, meaning if the whole thing's a fraction, take care of the top and then take care of the bottom. So the top says a single operation of 3 plus 9. So that gets me to 12. The bottom has a single operation of 5 minus 3. That's 2. Once I have it down to 2 values or 2 integers, now I can take care of the division, right? So if you have a whole top and a whole bottom, you have to deal with those separately first. So that's why it's special. But now we can actually divide. 12 does divide by 2 down to 6. All right, let's look at example 4. Let's go through our PEMDAS acronym. First, do I have any parentheses? I do. Okay, so yes, let's take care of parentheses. Let's underline what's in parentheses. That would be a 2 plus 3, which is 5. Everything else falls down. Do I have any exponents next? Nope. Do I have any multiply or divide? Yes. We want to go left to right. The first left thing I see is 25 divided by 5. That's 5. I didn't use the times 9, so it falls down. The last step is the last step. So 5 times 9 is 45. Now keep in mind, can a calculator be helpful with these? Yes, but calculators are picky. If you don't use parentheses appropriately, it's not going to give you the right answer. So some of these a calculator isn't very helpful. It actually confuses things more. And also because we're just learning this, I want to see your work. I want to see these steps. I want to see things underlined. I don't want to see just a 45 because I don't know how you got there. All right, in your notes, let's take a look at a couple more definitions. We haven't dealt with exponents yet for a reason. Let's talk about the word power first. A power has 2 parts, a base and an exponent. A base and an exponent. The exponent is the raised value, right? It's the little number that's above the bigger number. Raised value tells how many times to use the base as a factor. I'll give you a second to jot that down and pause if needed. The example that you have on your note sheet looks like this. So if I have 3, which is my base, raised to an exponent of 2, what that means is I have 3 twice, 3 times 3, which gets me to 9. A common mistake. Okay, this is a mistake. Some people say their answer is 6, and they just multiply the numbers. Well, we don't multiply a base times an exponent. We multiply the base times the base. So let's talk about how to simplify an exponential expression. So in this case, my base is 3, so I need a 3 as my base. But how many times am I going to write it? 4 times. 1, 2, 3, 4. We're going to multiply it by itself 4 times. Now here's where you can use a calculator. We'll work on that a little bit in class, but you're going to look for buttons on your calculator that might look like this, meaning 3 raised to the 4th. You might have a button that looks like this, where you get to fill in the 3 and the 4. There's some other options. I think some of them maybe even have this with a variable or a squared as the exponent. But we'll work on that in class together. I'm going to just mentally kind of multiply this out. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 10 to the 7th. Oh my goodness, let's write it out. That means I have 10 7 times. 1, 2, 3, 4, 5, 6, 7. So if you want to try it in your calculator and pause, feel free. But think of how many zeros that answer is going to have. Any guesses? Here's what's great about a base 10. This tells me that I'm actually going to have 7 zeros. You don't have to have that memorized yet. The key thing that I'm going to look for is, do you know how to simplify it and write it out? Alrighty, let's go back to our PEMDAS rules, but we are going to use our E. All right, let's start off with the first one, P. Do I have any parentheses? Yes, I do. 11 plus 14 is 25. Everything else falls down. E. Do I have any exponents? Yes, I do. 2 to the 5th. I'm going to do a little side work here if you have some space. That means I have 2 5 times. So I'm going to multiply that out. We've got 4. See how I'm doing this? 8, 16, 32. So 2 to the 5th is 32. The plus 25 falls down, the divide by 5 falls down because I didn't have it underlined, right? One thing at a time. Next, do I have any multiply or divide? I sure do. And if I read left to right, this is the first one I see. 25 divided by 5 is 5. The 32 plus falls down. Therefore, my last operation for addition and subtraction gets me to a 37. Again, feel free, if you have a physical calculator, you can use that to help you with the 2 to the 5th with your division. Ooh, look at this one. This is one of those special ones. Can you please draw a star by it again? What we're going to do is we're going to treat it like 2 separate problems to begin with. So we're still going to go through PEMDAS, but we're going to look at the top and then we're going to look at the bottom. So first of all, do I have any parentheses? Nope, I don't. Do I have any exponents? Yes, I do. I do have exponents. Sorry, let me fix that quick. I do have an exponent, 3 to the 4th. So you can use a calculator, or I'm going to do a little side work. That means I have 3 4 times. Wait, we just did that earlier, right? We did a 9, we did a 9, and 9 times 9 was 81. So the 4 and the plus carry over. But now 3 to the 4th is 81. The 7 and the -2 carry over. Now, because this is a unique problem, now we've got a single problem on top, right? We've got one operation, so let's take care of that. 4 plus 81 is 85. All right, that takes care of the top. Let's look at the bottom. On the bottom, I have 7 minus 2. That's a nice clean 5. All right, now I've got a single top, a single bottom. I can simplify that. Oops, I shouldn't circle it. It's not my answer, but I can simplify that now. 85 divided by 5. Again, feel free to use your calculator, but we arrive at an answer of 17. Let's take a look at just a couple more. Bear with me, you're doing great. The next problem, we're going to follow PEMDAS. First step, do I have any parentheses? Nope. Next step, any exponents? Yes. I'm going to take care of this 2 to the 4th. Well, we already did this one, but let me refresh your memory. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So that becomes a 16. The -1's still there, the 5's still there. Now, this is a special one again, right? See how I have to take care of that top first? Oops, sorry, I'm trying to erase here. Let's take care of the top, 16 minus 1. It's a big fraction. So if I take care of that, I've got 15. It's still over 5. And then I've got a nice clean division. So these ones are special. Remember, they don't quite follow the PEMDAS rules exactly. So treat the top like its own PEMDAS and the bottom like its own PEMDAS steps. And then the very, very last thing you do is take care of the big division bar. All right, let's look at this one. Let's go through our PEMDAS rules. Sometimes using a whiteboard can be helpful here because you can just have PEMDAS written down and just reuse it over and over again. First, do I have any parentheses? Nope, no parentheses. Next, any exponents? I sure do. I have 4 squared. Remember, that means 4 times 4. That's 16. Everything else falls down. Next, do I have any multiplying or dividing left to right? The first thing I see left to right is 5 times 7, 35. Bring down everything else. Ooh, I still have a multiply or divide. I've got 16 divided by 2. That's an 8. The 35 falls down and the minus falls down. And lastly, I have a subtraction piece. 35 minus 8 is 27. Now, if you were to try to just straight type that in your calculator may give you the wrong answer. Okay, so that's why it's really important to know your steps and break them down. All right, I know that was kind of a lot of examples, but there's some unique situations. So for your practice today, and as always, make sure you check out Google Classroom to see what you need to work on. If you have any questions, keep in touch. And until next time, have a good one.